In this tutorial, I'll show you the fundamentals of how to use scripts in the console and the expressions window of the Kinematik-Software ASOM version 7. First, I will make some simple coordinate queries, and later also some collision tests. Let's begin with a 4-bar system. I'll just create one in an empty project. Now I've created some arbitrary 4-bar system. I'll give this an animation by adding a suitable drive to the coupler. Now I'll give the coupler a more interesting shape using a polygon which could represent a real hatch, hood or door or any other desired shape. Let's test the animation. Here we see that the polygon is not yet connected kinematically, so I'll choose to connect it with the coupler. Now it is connected. Let's display the trajectory of one of the points. And let's also name it, or rather the point, P1. We'll need this later, the name. And the polygon, the area, we'll also name A1, area 1. Like this. Now the properties of these named entities are available to us in the console. First fact about the ASOM scripting language: if I type 2 colons in a row, then I can see all the possibilities, all the operators and objects and properties that are available to me for making a command. To access kinematic objects, I'll choose the namespace ASOM here. So colon, ASOM dot, and now I see all the objects I have named so far, plus one other, simulation, which represents the animation. Unnamed objects cannot be accessed. I'll type P1 dot, position current, for example, and press enter. These are the x and y coordinates of P1. If I only want the x value, I can access only that. By the way, you can use the arrow keys to iterate through the previously used commands in the console until you find the one you want to reuse or modify. So maybe this information is what I need, but I want to keep an eye on it continually at all times, so I'll copy the command and go to the expressions window, create a new expression, P1, x, current, enter, and this. Syntax error because we forgot the semicolon at the end. Now the script is syntactically correct, and there is the value. And as a side note, once again, everything is updated in real time. If we don't like to see so many decimal places, no problem. We can change that. Colon, because there is a command for that, standard dot format. Here we see a short description. What inputs do I need to put? First a format string, which I will put in next. Then the variable, which is already here, ASOM P1 position current x. The format string is open bracket, 2 decimal places, like this, comma, the variable, close bracket. The syntax is correct, and there is my current x value. In the same way, I could generate a y value, but I'll pass on that now. What interests me now, for example, is the minimum of this complete trajectory here and not only the current position of the point. So in this example, the minimum is over here. To compute it, I'll first move the whole system so that this point is in the origin of the global coordinate system. This way, the next steps are a little easier to do. I'll choose the feature translate here, then I'll select the point and move it Here I can see the coordinates, or I can activate the grid with this button, move it to the origin like this. Now the position changes for the point can be accessed directly. Otherwise, we'd have to subtract the point's coordinates, which isn't necessary now. Now I'm interested in the minimum. How can I find it? It's not directly accessible here, as we can see. P1 dot, it's not there. I could compute it in a loop, but actually there is an easier solution. For this, I'll first generate a data track here in sources by going on diagrams and saying I want the whole trajectory as data in the form of a diagram. So P1 track with this point as source for the x value and the same for the y value. Only here I want to have x on the x-axis and y on the y-axis. Like this. You'll see no axis labels here. This is intentional. All the labels are in the footer with the legend. The option to combine several graphs with different units in the same window makes auto-labeling useless. You can add custom labels manually though. So this is the x and the y value, and as the system moves along you can see the current values. And if I change the geometry a bit, you see how it also changes here. Let me just switch off catch mode, and now once more, there. Now all this data will be easily available to me, exactly as I want it. Now I'll move that over here, like this. I'll have to name the corresponding object though, that's the value stream over here. Let's say for the x value, to use this data. Value stream P1x. This would be the value stream for y, but I only need x for now. And now it is available to scripts in the console, of course, and also in expressions. There it is, P1x dot, and there is min and the maximum. In this case, very easily accessible. If I like this, and I want to create a watcher for it, I'll once again create a new expression in the expressions window, enter the minimum of x, and name it P1 x min. There it is, and this is exactly the desired minimum value. If I change the animation, then the minimum value changes as well, of course, and becomes 0 now, for example, since it now corresponds to the initial value. Now we come to part 2, collision testing. Here I'll begin by adding another object to my system. I'll just create another polygon. And name it. Remember, this is important because otherwise it would not be accessible to us through script commands. A2 area 2. And I look at the animation, at the movement of P1, but really of the whole object. That definitely collides. Even if P1 doesn't collide, the whole object certainly does. And what interests me now is if area 1 and area 2 actually do collide anywhere during the animation. For collision testing, I'll first head to the console, since there exist certain commands that can help me detect such collisions quite easily. Geometry, collide, this is what we need. Here we have to input several things. The object as geometric entity, then a boolean as outline. What is that supposed to be? We can look that up under help, script manual. And here we can do a full text search, find for the word outline. Then we find this, collide. This is the exact function we were looking for. The asOutline parameters determine whether the geometric inputs should be handled as outlines or as filled areas, as can be seen here. In our case, where no object will ever lie completely inside the other, it is actually quite irrelevant how we set as outlines, so we'll just put false both times. So geometry, collide, then ASOM dot A1, that's the first object, comma, as outline, false, then ASOM dot A2, the second object, and again false, and the output is false since there is currently no collision. As a check, let's move this around until there is a collision somewhere. Now there is one here. Reuse the console query with the arrow keys, true. Okay, now let's move this back a little ways. Like this. Then we'll take this and put it into a new expression so that we can watch it continually. Collision, current, put in what we copied, and we get an error. This one's simple. We forgot the closing semicolon, but that's not all. We also forgot the return command. Now it's correct. Collision current false. We animate true, false, and if we don't like the way it's displayed, we can modify that. For example, like this, if, open bracket, in this situation, please just return collision, else return no collision, and again the semicolon, and we get no collision. And we check, collision, no collision, great. But there is still a problem with our expression collision current. We don't actually see if there's a collision anywhere during the animation, but just if there is one at the current animation time. Furthermore, there is no provision for an offset in the script. So we'll address both problems, the global view and the offset, in one final script. So once again, collision check, and now we want to check the whole animation for collisions at once, and we also want to allow for offsets. For this, I first need a custom data source. This I can create here via diagrams, script data source. And I'll call that distance between A1 and A2. This should have an output of type length. And now I'll put this, okay, return was right already. So return, and once again we'll use geometry, but this time not with collide, but with distance. And again we input two objects, ASOM.A1, again with asOutline false, ASOM.A2, comma, false, and close. Again, don't forget the semicolon. Now the script is correct, and so as I don't forget what it is supposed to do, I can put something down in description here, like minimal distance between A1 and A2, over the entire motion. Like this. Now we have a script data source which we could later modify or delete again. This data source has not been used yet, not been computed yet. We'll do that next. For this, I'll use a diagram, which I'll create now. I'll just call that distance. And now I'll choose to display over the time, the animation time, which is one of several possible choices, our custom data source. We see a list of script data sources here, but we only created one. So there it is, our data source that we want to display. No other modifications necessary, okay. And now I find here the graph that shows us this distance. I'll close the legend. We can see that at one time over here the distance is 0 or less, and later it is greater than 0 again. You can see all of this at once, and we check. Now there is a collision, 0 distance, and now there is no collision, positive distance, and back here the distance is actually constant for a while. And one thing is quite clear, somewhere during the animation there definitely is a collision. Also, if I change the geometry, I can see now there is no collision, now there is. And what you can also see is this. I could now, for example, get a collision. There actually is no collision now, but if I added an offset of 8 millimeters, the system would show collision again. This we will now address in one final script. For this, I'll create again a new expression, collision over all. So if, and now we put the logic, ASOM dot, and there I went and forgot something. I forgot to give the object a name, as it turns out. So cancel, and then we go back and give our object a name. That's this value stream distance, like this. And again, collision over all. If ASOM dot, there it is, distance, and we don't just want any distance but the smallest one, min. Now we can set an offset. 0 or smaller would be no offset. We'll just put less than 8. Return. The rest we can do like before, collision. Else return no collision. Semicolon. And we get error. Okay, so there is once again something to correct. And it is quite clear what. The brackets haven't been closed properly. So collision, of course, since we're closer than 8 millimeters. I'll set this to 3 instead, then the system should show no collision. No collision, and that over the whole animation. Now I don't need to run the animation, but I see the result instantly at any time. Now I see that there is a collision somewhere, now as well. You can see this on the one hand here, and on the other hand by the minimal distance falling to 0. That's it for now. For practice, I recommend making some variations of this exercise by generating different queries. On the one hand, queries concerning kinematic objects. On the other hand, queries concerning graphs or data streams that were generated by diagrams. It could also be a good idea to use the script manual. It also includes some examples you could try and emulate. Thank you for watching.